Hey guys, good morning.
Good morning.
Appreciate being here to share with you guys. I appreciate the invite, and this should be a little bit of fun for you guys, something different. Brent Jeffries, Bierer Meters, Vice President Field Operations, Safety Trainer. I've been with the company Bierer Meters for about 10 years now, and actually this month begins the 10 years. And we're a family company. Walter Bierer, my stepdad, he's raised me since I was 5, so I call him my dad, obviously. He owns the company. My brother works there. He's executive vice president of the company, Joe Bierer, and his wife. And we have my nephew works there, Ryan Bierer, and then we have some uncles and aunts, and we're a family company. We're exactly 2 hours down 77 in Blythewood. That's our factory. And we have a live line training center that most folks don't realize that we have, but we do. We have some underground 3-phase and overhead 3-phase, and you are welcome to use it to enhance your training. Come on out and you guys can participate, whether it's a half day or whatever you guys want to do, and it's no cost. For me coming here is no cost to the Cooperative at all. I've been doing what we call a Lineworkers safety and tool was training, but now we're going to call it Competence because the reason why I changed it from tool training to tool competence is because by the time we get done here, we want you to know that you know that you know. And this training is going to be a lot of tactical. It's going to be a lot of psychological safety and tactical safety and tactical training. It's going to be about 3 different aspects. You're going to hear, you're going to see, and we're going to get some hands-on. So basically, we're going to cover everything that you need to be covered depending on how you learn. And all of you are a segment of those 3 methods of learning. And so what we're going to do is we're going to combine all 3 of those segments into this training. So it's going to be a real session, and we're going to talk about your electrical theory, but we're going to prove it's not a theory. We're going to talk about your electrical reality, about when you're working out in the field. We've been doing this for 7 years around the country. We spend about $1 million a year on safety, and out of our profits. Pretty much no other company does this, and I go around the country. I do statewide speeches, IP conference, incident prevention conference speeches, and so this is kind of cool. I'm a little rusty. I haven't done a speech since May. I had 3 detached retinas in my eye here, and I'm just now feeling like it's time to get back. I can't see you out of this eye very good, but in time I'll be able to see you, and it's probably best I can't see you that well. I mean, as far as the safety aspect, right? This should be kind of fun for you all and pretty good. This is going to be open forum. You all can ask me questions, interrupt at any time, and I'll be asking some questions back to you all as well for your answers. There's really no wrong question or wrong answers. This is how we learn, is we communicate. And whether it's right or wrong, we need to communicate. So, and let's just give everybody respect that we want to allow that communication amongst each other, okay? So it'll be a non-biased training. We use our tools, obviously, since we manufacture these tools just down the road from scratch. So we're going to use our tools for the training, but it's not a sales pitch at all. We have plenty of sales. We can barely keep up, so we don't need to be doing that. All right, and so irregardless, these things that you're going to learn today, a lot of things you haven't ever heard before, and these things are work methods, proper procedures, proper tool positioning, proper body positioning that might be new, but it's important that as you learn these things that you take them, and you're going to be sharing these things from time to time in the field with those around you, whether you're an apprentice or whether you've been doing this for 25, 30 years, it doesn't matter. We all need to continue learning from each other and help each other, okay? Because we ain't done until it's done, okay? So anyways, there's hats here if you guys want a hat. Real quick, ECOS. I started this about 2 years ago, Electric Culture of Safety, and I was given the idea as traveling around the country, time away from my wife, time away from home a lot. It's just like there's got to be a moment where as I get older that I got to chill a little bit and slow down and get some help. So I talked to some folks and said, hey, I got an idea. We're going to start doing Lineman Safety National webinars for free nationwide. So I went to the very best speakers in the country, and I said, hey, you guys are going to start coming to our Live Line Training Center, and you're going to start sharing with these folks around the country, and we're going to form a line team, unified line team, and we're going to share safety at no cost. Your companies are going to pay for you to come down to South Carolina, and it's going to be available to everybody who wants it. Different topics, different speakers, different subjects. It's amazing what's going on. Now we have over 10,000 registered members to Electric Culture of Safety. Over 10,000. And they receive our monthly webinars. We do 2 a month now.
Why is this happening? It hurts. Am I gonna die today? These are thoughts that flash through my mind as induction from 2 500,000 volt circuits surged through my body for roughly 30 seconds. The day that we planned on just doing our daily work, bare hand project. We've done it 100 times before this. Never thought twice about how the day would go, and this day was different.
If we practice for the event, we may not have to practice for the funerals. So that's from here, you guys. I'm not trying to bust your balls. That's what's really happening. This is what a lineman funeral looks like, and you don't want to go to one.
Don't think we're talking about leadership and executives and all that today. This is about you and I. This is about you and I, you and your family, all right? You need to own your safety, all right? Only you can have a positive effect on other people. You can also have a negative effect on other people, all right? But why? Why would we want to do that? Why would we not want to win the crowd? Why wouldn't we not want to build a successful culture? It's up to you and I.
When you get up in the morning, I want you to look yourself in the mirror, and I want you to verbally tell yourself, I'm going to save a life today. And I want you to do that each and every day. And when you come home at night and you get ready to retire and go to bed, you look in that same mirror and you ask yourself, did I do my number one task? Did I save a life today? And take stock, because there's nothing more important. We've all got tasks to do, but that's the most important thing that we can do.
And then I talk about this from the decision-making standpoint. These leaders have to be able to make decisions on the fly. And honestly, they have to be able to do this. Stop the job now. They have to make these decisions, and we have to empower them to make these decisions. This is such a strong duty that we just can't, we can't roll over.
I'll just summarize. Again, lead and protect people rather than managing robots, policing systems. Realize that hazards and risk are quantifiable and predictable. If we can predict, we can prevent. Make sure that we're focused more on self-reliance than over-relying on other people and things like protective equipment to protect us. And then use the hierarchy of controls. It works. It works. It doesn't work real well if we just settle, if we just start with PPE. It works really, really well if we have a conversation and really think about, for this task, how can I protect myself? And so I will again close by thanking Brent and Bierer Meters for the opportunity to be here. ECOS, the electric culture of safety. Get involved with that. I love what they're doing. So honored to be a very small part of it. Honored to be here today. And everybody, take what we've talked about today to heart. It doesn't do any good to talk about it and listen to it in a virtual format or watch a recording of it or see it up on the screen. it does a heck of a lot of good when we apply it in the field. So turn the words to action. Stay safe. Be well.
About January, I was going into the southwest territory of the country doing training, and I came across this poem. I want to read this poem here. And what I want you to do is, as we go through this poem, is listen to these words, because this poem was written decades ago by Mr. Don Merrill, and he's a safety professional. And he's seen a lot of incidences. He was with EMS, and he's seen a lot of real situations, a lot of hurt, a lot of blood. And it just, there's a point where it just bothers you after a while. And you want to do more instead of just being the same old, same old. You want to make a change. And that's what this is about. This is why I'm here with you guys. This is why you guys are here with one another. All right? We all complete each other. We all are a circuit. We all are part of a grid. And we cannot isolate and insulate ourselves from one another. We have to connect. We have no choice. And that's the only way this is going to change. That's the only way we're going to have that true happiness and really like our job. We don't have to like each other at all, but we can like our job and do our job. And part of our job is to work safe and watch out for one another. All right? So, chose to look the other way. I could have saved a life that day, but I chose to look the other way. It wasn't that I didn't care. I had the time and I was there. But I didn't want to seem a fool or argue over a safety rule. I knew he'd done the job before. If I spoke up, he might get sore. The chances didn't seem that bad. I'd done the same. He knew I had. So I shook my head and walked by. He knew the risk as well as I. He took the chance. I closed an eye, and with the act, I let him die. I could have saved a life that day, but I chose to look the other way. Now every time I see his wife, I know I should have saved his life. That guilt is something I must bear, but isn't something you need to share. If you see a risk that others take that puts their health or life at stake, the question asked or thing you say could help them live another day. All right? This is true. This poem, which was written decades ago, could have been written yesterday. Because that's who we are. We're human. And this utility, when I got there, I read that poem, and man, that was hard. Because 2 weeks before I got there, they actually lost a lineman on a live front, and he was working solo, which makes no sense on primary. All right, he was working solo. He didn't have a backup. He didn't have a wingman, and they lost that guy. And I had to read that poem, and I tell you, you could feel from their hearts, you could feel the vibration from them that they didn't want to hear it, because that was their reality. This doesn't have to be our reality at all, ever. Doesn't have to be. So here's a picture taken from about January. You see the lineman's up on the glass, and he's got his jib stuck, a little tangled up, and this is how he's going to get released from it. Okay? So, I'm sure he's not alone. I'm sure there's someone there with him that's watching this happen. You guys ever see a similar situation from time to time? Go through these things, get stuck, and you're in a hurry. You're embarrassed, and you don't want somebody to see. So what happens is you take one incident and you compound it with another incident. You see what I mean? Because you don't want to be seen. Because you don't want to be embarrassed. And see what happens is you don't want to be seen, you don't want to be embarrassed, and then somebody will get killed. Someone will lose arms because they don't want to be embarrassed. But now they're not here because they didn't want to be embarrassed. So they compound situations. And when we find ourselves out in the field working, there's a point when we gotta say to ourselves, because it's a decision. That's a decision. We gotta say to ourselves, we need to just stop. We need to pause just for a moment. That guy on the ground needs to say, whoa, let's talk about this. All right, let's learn from this. You see what I mean? We need to share. And then here's a picture of a guy. You saw Lito speaking, that first guy, Lito Wilkins. He's a cool guy. His story is amazing. I got his full video. All these ECOS webinars, you guys, all you got to do is ask. Just email me, and I will send them all to you, and you pay nothing. All right? These guys pay for it. We pay for it. But anyways, this is a picture taken of a line truck. And I want to read integrity over here. Perform tasks as your best work practices and training while alone or with other line team members. All right? That's what integrity is. Whatever you learn out in the training field, whatever rules that you're supposed to follow, whatever best work practices that you've established particularly for your company, we follow those things. We just do. That's just what we do. All right? And then discipline. Your code of behavior develops the essence and character of your line team, whether win, lose, or catastrophe. And that's the truth. Look at that. That's the back of a line truck. Do you think that attitude right there, do you think that could lead to an incident? Maybe whoever is managing their line truck, when they have any break or any time, while they're being paid, they're on their cell phones. Maybe they're on social media during the time that they should be working. Maybe straightening out their truck, maybe practicing their knots, right? Their ties. Talking to folks about, the next job. Talking to folks about the last job. What did we learn? What can we do to better ourselves? To influence one another. To live and be safe. That's what discipline is. You either have it or you don't. You could be disciplined to distracted line work, is what I call it, like a cell phone. I was doing training in Georgia Power earlier this year, and the contractor who did not receive any of the training, 3 of their trucks rolled out while I was training the guys. And I just looked over because I like to be observant. When you start this mindset, you catch things that without this mindset, you just don't catch. And that mindset is watching out for one another. I don't know these guys that are rolling out in their line trucks, but I'm still watching out for them. It just becomes part of your life, your discipline, your integrity, okay? And these 3 line trucks roll out, the contractor, and out of 3 trucks, now think about this, they're on duty. They're getting paid. 3 trucks. 2 of the trucks, the passenger linemen, who was a passenger, were on their cell phones. I saw them. They were like 75, 80 feet away, and I saw them looking down, and I saw the cell phone through that window. And they're in there texting and doing that. The wingman, think about this, the wingman that's supposed to be sitting next to the driver and being those 2 extra eyes, and having 1 eye right now, I tell you how much I wish I could have 2. And now that driver, instead of having 2 eyes himself, 4 eyes, his wingman and himself, he just got cut his ability in half to be safer and be successful that day. Think about it, 50% of that ability that's inside that truck, that mind, that consciousness of working safe and helping one another. So we get both of us, we come back. What if they're going down the road and you've got somebody that's coming in off of an offshoot? And the driver's focused here, but you've got that passenger that could be seeing more over here, peripheral, or more over here. Or maybe that passenger could see something that looks kind of shaky. Maybe that he sees a car up there, way up there, that's coming over, going into the shoulder, that's going a little bit over lines. There's potential there. You can predict these incidences way before they happen. But now in those line trucks, 2 of them, the ability to do that was cut 50%. Do you know what kind of score you get on a test if you get 50%? Do you know how far you'll get through high school if all you score is 50% through all your classes? You'll have to retake. You have to redo it because it wasn't good enough. 50% is not good enough. Any questions? This all remind you? Anything? So let's talk about OSHA here. The OSHA regs, we're going to call these the scriptures of alignment. These are your scriptures. These here were written because blood was shed. Folks died. Folks lost body parts. So rules were written to help compensate for these things. And this book is getting pretty thick. 1910.6269 is getting pretty thick. And we keep writing rules. All right? Because something happens. So, you know what? We're going to have to change our procedures. We're going to have to do this on top of what we used to doing because of this situation so it doesn't happen again. In 2004, OSHA did a T&D partnership. And in 2004, they went over deaths that have taken place, catastrophes, SIFs, basically. They went over. And contacts were the #1 killer. Contacts. Out of those contacts, there was a little over 500 incidences of death that they went over. And out of those 500 incidences of death, what they discovered, now check this out, what they discovered is almost 100%, it was like 99, 98% were completely, think about it, preventable. Completely preventable. So what they do is they write more rules to help prevent it. This ain't gonna help prevent things. All right, this here is all this is a foundation to build from. That's it. That's all it is. And then what you all do, EnergyUnited, what you all do is you take that foundation and you build walls. Okay? You build a roof. And what you do is this house of safety that you have to work from, this house of safety, this attitude, the consciousness of safety, is you got to stay in that house. Because outside that house, while you're working, if you go outside that house, there are beasts out there that will devour you. Electricity, a fall, a pinch, a crush. You got to stay in that house. And these are all preventable as long as you stay in that house. Do not open that door. All right? And if you want to look out the window, you can look out the window. But if you try to go out that window, sneak out through a shortcut, you try to sneak out the front door through not following what you guys have been training out in your training yard and what you guys understand is best work practices, things happen every time. It's provable. In 2004, if you fast forward 2004 to today, almost 20 years have gone by, and guess what's changed in the incidences out in the field? Guess. No thing. No thing has changed. The rule book got bigger, but no thing has changed. And the reason why it hasn't changed is because we are so human and we like to do our own thing. We get embarrassed. All right? We don't want to be reprimanded. Why? Because we have a situation that's built in our program that causes embarrassment. So we don't feel safe. It's not safe to fail safely. It's not safe to fail. And so what happens is we feel pressure. And we have to get that job done. And so we take those shortcuts because we got to get that job done. Because the system has not been properly built. All right? You might have a foundation, OSHA, a foundation, but maybe you built those walls and that roof out of cardboard. Maybe. And you get a big old storm and those walls are gone and people die. Okay? It's called storm work. You guys talk about doing storm work when the storm is right here. This is the storm that we got to go and rebuild. All right? This is where it's at right here. So let's read these real quick. And this is a good thing to do, is open those regs up. You've got some time and you're getting paid. Don't go to your phone. You get breaks. Go to your phone on a break. Go do your whatever on your own time. All right? Let's read these. Protected ground. This is out of lowercase n, 1910.269. And we're going to talk about your TPGs, your temporary protected grounds. And here's a section out of it. Protected grounding equipment shall be capable of conducting maximum fault current that could flow at the point of grounding for the time necessary to clear the fault. Does that make sense? Okay? Protected grounds shall have an impedance low enough so that they do not delay the operation of protective devices in case of accidental energizing of the lines or equipment. Okay? Or accidental could be unintentional. You know, someone throws in a switch at the switching room, and so these are good just to go over. These are really important because the employer is to be responsible for a lot of this as well, and to ensure the safety of their folks. The TPGs, I like to talk about that. That was Walter's first invention. He built the grounds tester 37 years ago, and since then, 37 years ago, he's got 17 patents. But what this grounds tester does is it puts continuous current on the TPGs, where other manufacturers, they'll use some current and their glorified ohms meter. So it's not a true test. The continuous current, Walter came up with this math up here, and what's interesting is the F855 ASTM, which are considered guidelines for the OSHA regs in lowercase n, they're considered guidelines. ASTM put my dad's math into page 2, table 1 in the guidelines. He came up with the math. I didn't know that until earlier this year. That's kind of cool. I thought ASTM did it. And what we're going to do is we're going to talk about your TPGs. And then when we talk about your temporary protected grounds, we want to consider these a best friend. We're going to talk about 2 best friends today. And you want to always take care of your best friend, right? You do. And these are to be considered a best friend. And your best friend, what you want to do is prior to use, is you want to perform a visual inspection and a mechanical inspection every time prior to use. Now what's amazing is doing this for 7 years, coast to coast, Brownsville, Texas, into Canada, even a little international, that I've gone to utilities, contractors, quite a few, and before I got there, they were not training their linemen to visually inspect nor mechanically inspect their TPGs, their best friend. They weren't. They do now. A lot of things, tens of thousands of linemen are safer today than they were 7 years ago. And that right there, I got that. That's awesome to know. So what we're going to do is we're going to look at your cable. You do not want to see any smashed cable. You don't want to see any crimped copper or cable. You don't want to see any oxidization on your components, especially your contact points of your clamps. Make sure they're clean, make sure they're brushed. If you can't see your copper, you don't want to see any blackened copper or oxidized strands. If you have a clear jacket, you don't want to see any cracks on your clamps or obvious loose parts. Make sure everything visually looks good. Typically, if they look good, your TPGs are going to perform well for you, typically. All right. The mechanical inspection, you're going to grab a hold of that clamp, and you're going to make sure that clamp doesn't spin off the ferrule. Make sure when you grab a hold of the cable, that cable is nice and tight in the crimps of the ferrule. Make see any air when you're wobbling. It's just smashed, strong. That's what you want to look for. And obviously you're going to look for a lack of loose components. So you're going to perform mechanical. I've gone to some utilities to where I have seen loose parts, blackened copper, broken strands. I've seen broken strands. And all these things, some of the TPGs that they took right off the line trucks because they were receiving new information, they never heard this stuff, is we put it on here And I would tell them that your TPGs, through the visual inspection, mechanical inspection, your TPGs, before we do an electrical test, which you also, the guidelines speak about, ASTM F855 and IEEE 1048. They both talk about it. They're good reads, really important reads. Hard to understand for me at first, okay? I grew up in the desert in Arizona chasing rattlesnakes and shooting bunnies. So, you know, I don't understand language very well, you know, raised by wolves kind of thing. So, you know, you get in front of these guys and they pull these off the truck and it's like, dang, they are a mess and they won't pass. And I tell them before we do an electrical test. But let's do an electrical test. Whenever you perform an electrical test, what you want to do is you want to make sure that you perform the electrical test with the cable in parallel. Right here. And what this does is it mitigates the magnetic field. So it mitigates it because the continuous current produces a magnetic field, and if you happen to have your TPGs coiled up, which we're going to show you, coiled up like this, hanging in the air, or maybe they're on your truck reel. You got some grounds on your truck reel, possibly, and you leave them coiled up like this, it creates a magnetic field. And this is your electrical reality. That current creates a magnetic field. And if it gets hit by a potential fault current, what happens is this cable will try to escape from itself. And if you're in the way, you're in proximity of that situation, and that cable tries, maybe the electrons start flowing through that conductor unexpectedly, unknowingly, accidentally, and you get this fault current for whatever reason, this thing will explode and run away from itself. And if you're in the way, you can get bopped. All right? Yeah, the TPGs, if it was on correctly, would save you and help protect you. But if you're in the way, they take you out. So you don't want to do that. So you want to go, when you're setting up your EPZ, your bonding and all that to be safe, you're going to make sure that your cable is going from point A to point B. Okay? Basically, straight. You can have some droopage, that's fine. You just don't want any coils. I did training in North Carolina last year, not too far from here, with a big contractor. And they were used to doing 115, 230, 69, a lot of transmission. And what they were doing is their assemblies for the higher lines, what they were doing when they got to the low lines is one of the linemen, at least, if not all of them, because he learned it from somewhere, is he said he would take his long cable and just coil it up and wrap it with electrical tape. So it looked all pretty cute hanging from that line. And he said, I can't do that no more. And I said, go to your boss and tell him that on those lower KVs that you need a different assembly. That's a little shorter. Just tell him that. And I said, I didn't say you can't do it. What did the class, what did the training show you? The instruction, what did it tell you to do? To do it or not to do it? What this is you got current running through here, and it's forming a magnetic field. Whenever current runs through anything, it forms that magnetic field, and there's a little magnet in here. Okay? So you see in here reality. This is your reality. Okay? Pretty robust there, isn't it? Okay? Now let's do this. Let's keep the same continuous current, and then what I'm going to do is I'm going to mitigate that magnetic field best as possible. When you electrically test an assembly, you want to put like a 2x12, build a channel, 2x4s on each side, pre-measure it out so it's all measured. You don't have to have a measuring tape. All right. Now I'm going to bring that same magnet. Okay. It's a lot less, isn't it? More humming. Okay. So it's a lot safer. That's what you want. Okay. So, thank you, Brent. So just remember, when you're all out in the field, that you want to make sure that when you're working with each other, or you go home tonight, see your family, that you do not go to your family or work with each other all coiled up. Keep it smooth. Okay? That's the reality. All right, so what we're going to do is we're going to go down to 250. because a 1 amp cable requires 250 amps to test. So we're going to go down to 250. It's getting a little warm now with all that current running through. Go 250. Okay, a little, about 250. And what we see is a 0.02 voltage drop. Y'all see that?
Yep.
Okay, 0.20 voltage drop. You go up to your chart and it requires a 0.38 voltage drop or less. And it passes. So this assembly passes. Very well, actually. All right, it's pretty new, as you can see. Okay, so this assembly, what you do is you're going to date stamp it. And when you do your visual inspection, make sure that you guys look at that date stamp to make sure it's in compliance. We recommend about every 12 months. That's typical throughout the industry. Some go 24 months. I think that's way too long. Some go every 6 months. I think if you're training your line workers to visually and mechanically inspect your TPGs, 6 months is too often. Let them know, let them take some responsibility as far as watching over and looking after their best friend. 6 months is way too much, okay? The regs don't tell us how often. The regs don't, the guidelines, ASTM and IEEE do not say how often. I think that's wrong. I just think it's wrong. Because I know some companies today, some very large companies, that this very day, they still, believe it or not, do not test their TPGs electrically. That is, to me, insane. Because, see these words right here? How do you prove your TPGs are going to ensure safety for your line worker? Unless they're tested electrically. You kind of don't know, for sure. So you want a date stamp. Make sure that date stamp is in compliance. When you're out in the field, you could get inadvertently skipped. And make sure that your date stamp is in compliance with your protocol. Make sense? Okay, guys? So the first thing we're going to talk about is the battery test. So your voltage detectors, whether they're ours, remember this training is regardless of whose tools you use. It doesn't matter whether they're ours or somebody else's. We have a switch plate that goes to test position. Some folks, they put a push button that goes to test position. A battery test is a battery test. A battery test just tests the battery. Our battery test goes through about 90% of the components inside. It's a pretty good indication that your tool's gonna function well for you, but it's not sure. It's not 100%, let's go. It's just a battery test. Anybody's tools. I was at a utility several years ago, and a large one, and I was in front of the work methods people and the safety people, and they used a different tool, which is fine. And I started going into the battery test, and they said that they trained their linemen, and they have been for decades, hundreds of linemen, that the battery test is a true tool functionality test. All right, so tell me, you're using the tool on high voltage, and you're testing a 9-volt battery, your battery test, and you're telling me the tool is good on high voltage. That's completely false. There is no transformer inside anybody's tools that's stepping up 9 volts to high voltage for a true live known voltage test. None. It's just a battery test. So if you use a horn and light or ever go somewhere or been somewhere that uses a horn and light, a noisy maker, you want to see and hear. Okay. If you don't see and hear, change out the battery with a known good battery. You just simply change the battery, take out the quick change where your live line tool goes onto. You take out the quick change, bump it a little bit, battery comes out, put a new one in, retest. If you don't see or hear one of them or both, then the tool's bad. Tag it, send in for repair. We build all these tools from scratch. If you use our tools and one is broken, you dropped it out of the bucket, whatever you did, ran it over, or whatever, we can fix the tools because we built them. An analog tool, these are the old school tools. These are well known throughout the industry. Battery test, you want to see that needle deflect. Y'all see that? See that? Is it deflecting? Good. I don't know. So if it deflects, you want to see it deflect good, fast, hard, all the way. If it's partial or doesn't move, change out the battery. If it's still partial and doesn't move, the tool's broken, send it in for repair. Real simple. A lot of repairs we get into our shop, all we do is change out the battery, we charge them to send it back. Because they weren't trained to do a battery test. They weren't trained. They didn't know. So always check the battery. Digital, I prefer digital's much better than horn and light, much better than analog. The reason why is because digitals are more robust. They don't have moving parts, first of all, like the analogs. The springs, the needles, all these things that we want to move in those analogs, all these things, if they're dropped, tend to stretch, bend, things like that. They're still robust, absolutely. But digital, there's nothing moving except electrons. So they're much more robust. But on top of that, digital gives you more information. Digital gives you a lot more information that I believe our folks need to have. And the reason why is because knowledge plus understanding, which I hope you guys are getting some understanding today, I hope so, equals safety, right? Success, efficiency, job done. So it equals safety. So we want to make sure that we have that knowledge, understanding equals safety. These are better. Typically the utilities contractors are going digital these days. Through what do you call that? When something breaks down, you replace it, but not until, huh?
I said, here it's attrition.
Attrition. I'm not talking about people getting old and breaking down. I'm talking about tools, attrition, okay? So that's what's going on, and it's a lot better. So when we do a battery test on a digital, check that out. It gives you the battery voltage, huh? That's more information. What's your name?
Adam.
Adam?
Yes.
Adam, you see that?
I do.
Okay, good. All right, so it gives you more information. Does that make sense? We know the battery's good. If you're seeing 7 volts or less, change out the battery. 7 volts, all right? So your accessories, you always want to use the proper accessory. Whether it's a straight probe, as this one has, whether it's a hook probe, always use the proper accessory, okay? Do not use your tools, whoever they are, do not use your tools without the proper accessory. This here is considered a shortcut. And when you take these shortcuts, you're teaching others to do, and it's okay. You're condoning the shortcut, and you're training and teaching others that it's okay. And it's not okay. The reason why it's not okay is because there's a line limit right here. And this line limit, about 2.5 inches down, ASTM 1796 said that you got to have these line limits. I think we're the only manufacturer that does. Seriously. And what that does is, and ASTM is recommendations or guidelines, right? So you don't necessarily have to, but we do. And what you do is we have resistors on the other side of this line limit. And that line limit is to remind you that that's where the resistors are, is right here on the other side of that line limit. So when you're using these tools, anybody's tools, they have resistors in them, like ours. You do not want to bypass those resistors with that primary power. You don't want to bypass those resistors. Because if you bypass the resistors, you bypass the protection, correct? You bypass the protection of those resistors that they offer you. So, always use the proper accessory, and the reason why is because if you're out in the field and it's foggy outside, maybe it's dark outside, your depth perception might be hindered somewhat, and you might not realize where about that conductor is. You got an extendo stick or whatever, where about that line limit is. It's hard to see, obviously, and you're going to visually look at while you're using the tool. Yeah, it's about 2.5 inches, but I can't quite see 2.5 inches. But if you have the proper accessory, it's easier to see. And you use the accessory to make contact, not the cone tip. Make sense? Always use the proper accessory, okay? Care on these tools. What you want to do is you want to make sure, I'll leave that on. You want to make sure that you keep them clean. You don't want to see any cracks. You don't want to see any damage, obvious damage, and you want to make sure that probe is clean. You can use your hot stick wipes. You don't want to see any dirt, grease, oil, or anything like that on the probe because you can have exterior tracking, right? Inside, we put epoxy and we bake it. As far as I know, we're the only company that does this. We do that because, one, it keeps internal tracking from ever happening. Elements, moisture getting inside the probes. If you cut this probe with a hacksaw and cut somebody else's probe, you'll see their probes have the wires all flopping around and that they're hollow. Okay? We put more resources into our tools because we make our stuff safer. We can do that. We're a family company and we don't have to put money into people's pockets other than us. So we put that into resources. They're very safe, very robust, very safe. I was at one utility in Ohio. I've never seen this before, but they were using a tool to go into a hot bushing when they were doing some underground work on their pad mounts. And they were using their tool, it wasn't ours, they were using their tool. And what they did is they had that interface for the bushing, a 15, 25 kV interface, was pure metal, tubular, just pure metal, and they were going into that. So you go into that and then you have all this exposure out here. What we do is we have that interface, but what we do is you're going to put that on your tool, and when you go into that hot bushing, that feed through, whatever you have, maybe you're high potting. When you go into that hot bushing, you're going to have this protective cover. They never even thought about that. It's amazing. They do now. They made some changes, so that's good. All right. So, real quick, the switch plates on our tools, voltage indicators, phasing tools, what we have is we have a URD, underground residential distribution, and that's letting you know that you're telling the tool that you're close to the ground plane when you're using the tool. All right, you're telling the tool that. We have a URD and we have an OH. When you use an OH, you're telling the tool you're further from the ground plane. This is wireless, so when you tell the tool you're further from the ground plane, the tool is going to be more accurate for you in that scenario. No one else does that. It's amazing. It's kind of cool. We're unique. So it's going to be more accurate. Okay, this is good. This is a cool one. We're going to talk about a math equation, x plus y equals z. So this is an equation that's actually really important. X always is your conductor. Whether it's energized or de-energized, X is always your conductor. Okay, simple. Plus Y. Y is going to be your tool functionality. Y is how the tool functions. And how these tools function is so simple. Whether it's ours or somebody else's, always remember these things, is we have a wireless. So what they do is they make contact with the conductor, X. The Y is the tool functionality. How? Why? How does this tool work? You need to know how the tool works. It's so important. It couples with the capacitance, and that current flows through the tool. Not the full primary, because you have resistors, but a chunk of that power flows through that tool, and it goes through the tool. The tool does the math to give you the voltage indication in relation to what? Right here, ground plane. See how that works? And it's important you remember this, because you all, your bodies that you're borrowing for a short time, it's not who you are, you're just borrowing them, okay? You're going to let them go one day, hopefully not anytime soon. But your bodies, where are they from? Dirt and water. You see, ground plane. So it's important to remember that. All right, always important to remember that. We'll get more into that. So it looks at the current in relation to the ground plane and it gives you a voltage indication. Isn't that cool? That's how they work. Now, that's the tool functionality. Equals safety. Everybody is using the tools and they thought it equaled the indication. In phase, out of phase. Oh, we're on 7200, it's about 7200. Or it's de-energized. We always thought that equaled that indication. And it doesn't. It's never equaled that. It has always equaled Z has always equaled safety and accurate. And this is important because we're not looking just for information, okay? A lot of folks look for information, but they don't know the why and what's going on. They just get handed, oh, here, okay guys, here's your voltage indicators. Go to work. And they're not explaining on how these tools, which they're supposed to trust with their life, they're not explaining how they work. Huh? True story. All right. So what we're going to do is we're going to always know that X, the conductor, plus the Y, tool functionality, equals safety and accurate information gathering. You guys get that? Simple. All right? So the corded tool works exactly the same. But, yeah, the secondary probe right now is stuck in that cable on the ground lead of that cable that's feeding my grounds tester. That's where the secondary probe is. So that goes to ground, right? So a corded tool, anybody's, works exactly the same, but it looks at the current in relation to the ground plane, not through the air, but through the cord. Is that cool? Same principle, but through the cord. All right? Any questions thus far? Good?
Are all of our tools wireless? That we use? They're all wireless? We don't have any corded?
Yeah. If you reference the phase of the ground with a phasing stick, you're actually physically checking it to neutral. Yeah. But our voltage testers are just proximity, but they give you what seems to be close to system voltage.
So they're non-contact.
They are, the one I have is contact.
Okay, good. We'll talk about contact and non-contact in just a minute. So line limit, we talked about that. We're going to skip that.
You got the HD.
Yeah.
What's the accuracy difference between the corded and the cordless?
That's a good question. This corded tool, PD25, is the most accurate tool in the industry. Seriously, we're not making that up. It gives you true RMS voltage plus or minus 1%.
That's pretty dang close.
It is so close, it's ridiculous. Nobody else has one that close. This is an amazing tool if you're working in a cabinet that's tight quarters, you have phases close by, or maybe you're in an underground vault. And a non-corded tool gets a little confused sometimes with everything that's going on there, because your electrical reality in those tight quarters or in those underground vaults, your electrical reality is flowing all around you. All around you. And this cord keeps it from getting confused. Now on our wireless, we kind of do something that no one else does either to keep them from getting confused, and we use a non-metallic insulating paint. Okay? No one else does that either. Huh? We do a lot of things. But yeah, so our wireless are actually very accurate as well. And you're going to see that today when we go further. Good questions. Any other questions?
What do you got it hooked to right now?
So the secondary probe, and I could just remove it because it's so close to the ground. I don't have to have it in the ground plug. We'll do the rest of the training with it out of this plug. Here's the secondary probe right here. Okay, so it is a two probe device where a wireless is just one. Okay, now we do have an adapter that goes on the end of the secondary probe with an alligator clip or a C-clamp, to where one guy can take this and go ahead and go to a ground, connect it to the ground, and then use the tool as a one user tool. Okay, we do have that. But I'll leave this out for you guys.
So you've got that set up to put a stick on that one and a stick on that one?
That's right.
Okay.
That's right. Yeah, you'll have a stick here. Like if you're a high-potting with this
Yeah.
tool, you're going to have a stick here, obviously, and you're going to have a stick on your meter probe. Secondary probe and meter probe. Okay, stick. Okay, I'll just leave that right there.
How much insulation's on that cord there?
Okay, this is another thing that no one else does, and that's a good question. But our cord here is insulated to 35,000 volts. We're the only manufacturer that does this. This is a custom cord that's built 2 hours from here. And other folks, what they'll do on their corded devices is they have that little thin wire that's coiled up onto a reel as far as their tool. That's part of their tool. Remember we talked about what happens if that cable gets hit with a fault current? What happens to that coiled up cable? And yet there's manufacturers that build their tools when they're going phase to phase, and their tools have a built-in coiled wire. Think about that. That's kind of like oxymoron kind of thing. But anyways, we build this cord. You can use our corded device with the cord on the ground. You can use our corded device with the cord laying over the cabinet when you go phase to phase, verifying what's what, or IDing cable. It's fine. Okay, you can lay on a metal lid, whatever. It's very safe.
Well, that makes way more sense. While we're using it, and to uncoil it just seems...
First of all, to uncoil the coil is what you want to do, because you don't want it coiled when you're using it. What if it gets hit with some high current, man? What's it gonna do? And if it's close by you while you're using it, what's it gonna do?
Do you ever have anybody come back and retest that? I know it's rated for 36,000 volts, but you ever come back and test it?
Yeah, so what we do is we suggest that you calibrate your tools every 12 months. If a tool comes in for recalibration that's a corded tool, one of our corded tools such as this, then we test that cable as well as far as accurate working. Now, as far as visual inspection, remember the care part. If you have a corded device, you're going to want to visually inspect that cord and make sure you don't see any nicks or big abrasions. If you do, you want to replace that cord just to be safe. Okay? Great questions. Let's talk about this. This is a big issue going on out in the field these days. It has been forever. Is tool gloving. And the reason why they do that is because they didn't know any difference. The lineman didn't know any difference, wasn't taught how these tools function, so they didn't know anything as far as how they function, so they just assume that tool gloving is safe. So what this is here is, remember that equation, X plus Y equals safety and accurate information gathering? Remember that? Remember how the functionality is, the tool is looking at the current relation to the ground plane, but if I'm tool gloving, what's the tool looking at as far as the ground plane? That's right, because we're from the dirt and water, right? So this is unsafe. But what happens is the equation goes from X plus Y equals Z to X plus Y plus U equals no safety and inaccurate information gathering. You're talking about using a tool that gives you approximate. Well, that's what you're going to do here. But not only that, it's unsafe. So you're not getting, remember approximate voltage? You're not getting that accurate information gathering, and it has never equaled safety. What you want to do is, when you're using these tools on your stick, is you want to always go back. We train 36 inches away from that meter head, minimum. And you're going to put like a hand guard. You can use electrical tape, some indication that lets you know that you have your other best friend that we're going to talk about a little bit here in this last portion, called the air dielectric. She's your best friend as well. TPG's your best friend, air dielectric your best friend. So you want that visible, right? When you work on a circuit, you're going to make sure that you're de-energized. You're going to have lockout, tag out. You're going to have a visible open air gap, correct? Well, that's what we're doing here. Visible open air gap. Keep the equation X plus Y equals Z, not X plus Y plus U. Because what happens, remember how these meters work. They have so much surface area. They're so large. Whoever tools you use, that's how large it is. That's just a fact. And they use that mass in relation to that current flowing through it to give you an accurate reading in relation to the ground plane. But what happens is, if you take, switch this around. If you take your tool in your gloved hand, your tool, what happens, it becomes a bigger tool. Correct? Because now the tool's this big plus me big. So now that the information that it's gathering is so incorrect, it's a joke. And it's never been safe. Never. Okay? So make sure you stay back. Keep your air dielectric. I was doing training in California, a large utility in California. After the training, a journeyman lineman came up to me, all gray-haired, probably 25, 30 years experience at least. And he came back to me, and afterwards, everybody's gone because he didn't want to talk to me with people listening. and he had a horn and light meter, and no one ever told him that using tool gloving was unsafe practice. No one ever told him that. The company, all their linemen, none of them knew, and they weren't sharing, they weren't training. And he went to that, he was all his life going to capacitive test points. Do you guys use capacitive test points? On your elbows? Yeah, okay, good. He went to capacitive test points by tool gloving. Well, this one day, and it's just a one time that these things happen, okay? These incidents happen. Never happened before until it happened then. Well, I guarantee you, these incidences that you think are freak accidents or just a fluke, they just never happen. They happen all the time. All around the world, they're happening. Maybe not to you today, but it could happen to you 2 years from now. And he went to that capacitive test point with his gloved hand. He had his hot stick adapter on the end, which this does not, but he had his barehanded. He went to that capacitive test point barehanded to get an indication, hot or not, see if it's energized. What do you think happened? Current's flowing through the tool, right? So your capacitive test point's about 10% of your system voltage, more or less. And then the resistors at the end of the probe, they break that down so it's not quite as strong. But whatever it was, maybe 100 volts or something, when he went to that capacitive test point, he felt that 100 volts. Completely felt it, because it went to ground. He didn't use gloves, and he was tool gloving, and one time he decided, for whatever reason, unconsciously, he just left his gloves at the truck or at the side of the job, and he just went barehanded at one time. He'll never do that again. I guarantee you he'll never barehand his tools ever again. And I guarantee you now, after the training, he won't tool glove ever again.
I bet he won't let nobody else do it either.
He won't. But here's the thing, and I gotta share this with you. This goes into another thing. First time this ever happened, it was really a neat experience. But the safety guy came up to me and said, "Hey, before you get started, we're gonna have a tailboard. We're gonna have a tailboard here, about 15 minutes." And I'm like, yes, because I want to get experience. I want to hear what's going on. And what they did is they opened up the floor, and I've never seen this before. They opened up the floor that anybody could share openly and freely, without retribution, without being ashamed, any incident that took place over the last week. They did it. And there was 2 linemen that stepped up and spoke, and they talked about incidences, they were minor, that took place. But I'll tell you what an environment. An environment, think about that. Remember the house of safety, where it's safe to communicate, it's safe to talk, it's safe to share about an incident that we all make mistakes. Every one of you folks today are going to make mistakes, multiple. We always do. That's what living in this clay body does, because we're not perfect. All right? And we always make mistakes, but what a neat experience to see those folks open up the floor to freely share. And nobody made fun of them. Nobody looked down on them. Nobody. But what happened was everybody was learning from their mistakes so that they don't relive those mistakes. Huh? That was awesome. That's what we need to do.
We have a good catch program like that.
Good.
And every month all the ones that have come in the month are published, and I mean, that's, for me, I don't know about the guys, but for me, when we go through it, it's an eye-opener for a lot of the things that I've seen here, but we share it amongst all the regions.
Yes,
it is for us.
That's awesome. Oh, it's neat, because that brings family. Sharing is, we hear that sharing is caring, right? But what happens is it brings that team together, that teamwork together, and the team needs to know. You practice a play. You practice a play and it didn't go the way it should have gone. It's because somebody didn't know their position, somebody didn't know the procedure, exactly where they needed to be when. They didn't hold back just for a few seconds, or they went too fast for 2 seconds too early. All right? But what happens is when we speak about these things, we practice these things, practice makes proficient. And then before you know it, these plays are going off and the team's winning every time. The team is winning every time because you're controlling the ball. It's not about scoring touchdowns at all or making a hoop That has nothing to do with it. It's about controlling the ball, and the ball is your mind. Is staying together right here, consciously. And that's what a true team does. All right? And you always will win. Okay? Everybody will always go home. They will. And everybody will retire, and everybody will see each other's kids and experience each other's lives and be happy. Everybody. So that's good. So then another thing I want to talk about is the short sticking. So we talked about the physical size. Don't be the bigger bird on the line. Same thing. Don't be X plus Y plus U. That bigger bird, the little birds can land on the line because their body, their mass, does not couple enough with the capacitance in relation to the ground to where they get shot. The big birds can't land on the line because they're bigger birds. All right, so that's the principle here. Short sticking, basically you're wearing gloves. And again, you're not keeping that 36 inches. Corded or wireless tool, it doesn't matter. And basically, maybe you're tired and you're in the bucket and you're just doing some short stick. We don't do that because you don't have your air dielectric and the tool's looking at you. Tool sees you. All right. Remember, you got to be 36 inches away. So we talked about corded tools a little bit right at the end last session. You got to be 36 inches away from the cord. The cord is part of the tool, right? You got a meter probe. You have your secondary probe. That's all part of this tool. It's a package. So you want to be 36 inches away from the cord. Well, short sticking takes that out of the equation because you become the equation. All right. So make sure you're not short sticking. Talk about the cord. The cords. Ray, you talked about putting a resistor into the cord itself here. All right, that's freaking dangerous, man. Because what happens is, why don't you just let the resistance be all right here, and let that resistance here protect the cord back here? Why do you got to have resistance here to protect the cord here? It's just another working part. Just do it all right here. We got 25 mega ohms of resistance right here. More resistance than the other manufacturers, and that's how we roll. All right. At the most, at the peak, you have about what is that? Half a milliamp of current actually flows through this cord at the max. All right. So very little. Okay. All right. Any other questions? You guys good?
Do you find that this choking up on the stick thing that you're talking about, because this is what happened over time. We started here before I came here as not doing energized work, and then they transitioned to doing energized work. So I'm gonna say everybody in this room has always done energized work. So we've always gloved the primary from day one. Once we got to that point,
Yeah.
do you find that training to do hot work, and that's what way you do it, has led to this sort of thing? People putting the voltmeter in their hand, because before we had voltmeters, before we put a ground on, it was legal to fuzz the line.
Yeah,
you
that's
put a
right.
metal wrench in your hand, you listened, you didn't hear anything, and that was testing it. Do you feel like that's what's led to where some of this stuff has gotten to?
Yeah, so, when you're fuzzing, you're in very close proximity to those conductors. So if someone gets hurt, they do a new rule.
Yeah.
So now you got to use your tester. You got to have a tester to fuzz the line with, more or less. But yeah, it's evolving.
Well, I've tried to share with my guys, that things have grown to where it is today, and it just doesn't seem like that has been enough of an education tool that's been shared to let people know,
Exactly.
I know that I've seen people put hotline clamps on by hand,
Yeah,
and we're like, we don't do that.
that's right.
We're at the end of an 8-foot stick for a reason, because if something goes wrong, you don't want to be there
Yeah.
with that violent reaction. But just get people to understand that yes, we do hot work, but there's things we don't do hot,
Right.
if that makes sense.
Yeah, so what we're doing is going over all these tools, going over proper work procedures. We're going over building this house of safety. And what we're doing is we're creating more capacity. See, you could have safety built on this foundation where you're living in an outhouse. That's it. That's your room. That's your room of safety, and it stinks in there. It's uncomfortable, and it's just not a great place to grow up and live in your so-called house of safety. But what we want to do is we want to have plumbing, we want to have electricity, we want to have AC. We want this house of safety to be roomy. We want maybe a cathedral ceiling here and there, and we want to make this beautiful and build capacity. We build capacity so that we can fail safely and be more comfortable. And when we're more comfortable, home is your castle or whatever, house is your castle kind of thing. So we got to build this castle, where it's safe. The walls, the moat, we got to have lookouts, right? Got to have some cool archers, because when you get out of that house, everything's trying to kill you, man. You walk through Africa. Try to walk through Africa on a safari just by yourself at night, without no gun, without no protection, and you won't go very far and you'll be dead, okay? You'll be dead. And that's what happens. You can do this long enough. You might get a mile down this safari, all right, your hike. You might get a mile one day, or you might go 10 miles. But what happens is you've got to be aware that the truth is that there's a lot of unsafe beasts out there that all their job is to do is to kill you and take you out. That's what electricity wants to do. It wants to kill you. It does, man. I'm going to go over more of that in just a little bit, okay? It wants to take you out. So this is super important. Proper body position, proper tool position. I get a call from a guy in Illinois, Cooperative in Illinois, lead lineman, and he says, "Hey man," he says, I'm going to go with this. He says, "I'm using your analog, and on 7200, I'm getting 13,000 volts on 7200 with your analog." So lead lineman, he says, "Oh, we just got all your tools calibrated. We've been using your tools for about 6 years." This is about 4 years ago. And he says, "They just, all of a sudden, your tools suck, and we're just not happy with your tools." So, I didn't want to argue with the lead lineman, because they know everything, and so you don't want to argue with them. And I flew out, and I did an hour class indoors, and we went outside and I did another hour outdoors in about 8 inches of snow. And it was cold like today was here, but 8 inches of snow. And he gets in the bucket truck. So here's a corner pole, okay? We have energized three-phase. We have energized lines going this way. We have energized lines going this way, all right? He's at a corner pole, and he takes the broke tool, and he gets up in that bucket truck, and he gets back on his stick. He gets in the exact same location he was when he had 13,000 volts. He makes contact with the tool onto the energized source, and he gets about, on 7200, he gets about 7400 volts. Pretty accurate for an analog, wireless, pretty accurate. He gets down out of the bucket truck, and he explains to me everything that he was doing wrong in front of everybody. The lead lineman, think about it, the shepherd of the sheep. You're talking about, understanding and, where we've come from, where we need to go still today. And so this is part of that. He came out of the bucket truck, and he told me, and this is so important, and he confessed that when he called me up, that he was in the bucket truck, he was short sticking. And he had his back to the enemy. He didn't consider the enemy back then. But I consider, if you're working hot, that energized source is my enemy. Okay, it's a beast, and it wants to kill you. And you better watch where it is and know where it is and what it does. Okay? And this is what he was doing. And what happened is that energized source behind him was flowing across and through his body, across his gloves. He had all his PP on, across his gloves, through the tool this opposite direction, because it'll work that way too. And then the conductor here, that current was flowing to this tool in relation to the ground this direction. So he literally became a wireless living, breathing phasing meter out of phase. Because if you're on 7200 and you're phasing and you're out of phase, you get about 13,000 volts. Isn't that right?
Yep.
And that's what he got. Pretty accurate phasing meter, his own body. He didn't know. No one ever taught him that. So proper body position is so important. All he did, here's when he called me. Okay, bucket truck is in the same location. All he did was go like this after the class. And the enemy is in front of him. Okay, and he got an accurate reading. So proper tool position. Proper tool position is if I come in on a vertical stack and I come into the middle phase, I'm going to want to be perpendicular to the bottom with my tool and as much perpendicular as possible with the top phase. You guys get that? And perpendicular to that long source. So I don't want to run this tool at an angle like this, because then it becomes close to the same potential. The closer, more parallel that tool gets, and maybe I don't have no voltage. Huh? It's de-energized, and it's not. It's the same phase. What you want to do is you want to make sure you go perpendicular. Okay? Always. Try as much as possible. Now, if you're on a horizontal stack, it's the same principle, same thought process. If I'm, this wrist right here, okay, this is a pole, and I got a pole ground on this. Well, let's say this. Here's a pole ground. If my tool is close to that pole ground, and I got an OH, because I'm overhead, I'm further from the ground plane, but I'm close to that pole ground, will I get a higher reading that's not quite so accurate because the tool is looking at that ground there? Will it? Should I see a higher number? And that's what you do. You do. So you got to make sure your tool's in the proper position. Keep them away from other sources the best way possible. If you work substation, you got a lot of ground planes nearby. And so if you're working a substation, you may need to go to URD. Because the ground, you might be high up in the air on some of that transmission coming in, and some of the feed going out. But if you're high in the air and you've got ground planes around, you know how the tools work. Go to URD, and you'll get more accurate. I just had a call recently about this, just about a month ago. Okay? And they're like, well, we think we know what's going on here, but is this what's going on? And yeah, absolutely. Okay? So make sure you have proper tool position, proper body position. That's important. That's Caleb. He's a cool guy. He's done two of our Lineman Safety National webinars. Caleb was participant and speaker. He's got some good stuff, man. Good man. Okay, this is a good one. These 5 steps. So in OSHA 1910.269, right here, it talks in number 5, when it talks about your TPGs, you're going to place your TPGs. Prior to placing your TPGs, number 5, right here, talks about how you guys are going to use your tester to verify de-energized, right? So basically, the steps are open, test, ground. Right? Open, test, ground. So what we're going to do is, we're going to do it 5 steps. What we're going to do is, first thing we're going to do is take our tester and we're going to test it on a live known voltage source. So when we arrive at this location, we keep the switch in. We're not going to get a clearance yet. And we're going to take our tools and we're going to go to that conductor, overhead or underground, and make contact to verify our tool's working properly on a live known voltage source, right? At the same time, what we're doing that for is because we want to make sure our head's in the game. So we're going to stay energized. We're going to be real. And Ross and I, when we get to this location, Ross is going to verify at this time that my head's in the game and I got his back. And I'm going to verify that Ross's head's in the game and he's got my back. We're energized. We're going to talk about it. Ross doesn't like me. I don't like him. Okay? But that just doesn't keep us from doing our job. I've got to watch out for him. He's got to watch out for me. And we're going to make sure that we're accountable. We're going to make sure that we're watching out for each other. So we're going to keep it energized. Then afterwards, we're going to go ahead and de-energize. Okay? We're going to get that visual open air gap. We're going to get our clearance. And we're going to be safe. And then what we're going to do is we're going to go ahead and test. All right? So we take our tester. We make contact with whatever conductor you're working with is called. We make contact. The meter shows us we got 0. Doesn't matter if it's horn and light. You don't hear nothing, see nothing. Analog, the needle don't move. And the digital, you just see zeros across it. All right, so you know you're de-energized. But then what we're going to do is we're going to test the tester again on a live non-voltage source. This is another extra step. All right, because remember the battery test doesn't do that. So we have a 3 kV power supply right here you could use, and we have our newer handheld power supply that you can use to test your tester on a live non-voltage source. Maybe you're at a storm or maybe an outage. You don't have a live non-voltage source because you got to do the test to test your tester on a live non-voltage source. Here it is. You can take it with you wherever you go. You see that, Adam? Okay. Good guys. Okay. Test your tester. Always test it because you want to make sure your tester wasn't lying to you. Okay, and tester's not lying. That's a live no voltage source. Then now we can ground. Is that cool? So 5 steps. Test, open, test the tester, ground. And I think the regs need to be changed. A lot of utilities and contractors, when they see with their eyes these 5 steps, they actually make huge changes in their work methods. And that is awesome. Encore just went through that last year. They changed their work methods. All their linemen, about 800, 900 linemen. In Texas, that was cool. That was fun. All right, so test the tester. You can go to, here, this is 002 Lineman Safety and Tool Training. You can go to Bierer Meters YouTube channel and you can get all these videos, safety training videos for free. Some are full length. Some are pretty good. All right, then we got some short clips too. We got a lot of short clips. All right, this is important. Zero ohm extension. Man. Zero ohm extension. So what we got here, if you are using your tool, you're going to go into this area, regardless if it's underground or overhead substation. And if you have close proximity, energized sources, close proximity, or ground planes in close proximity, say a bleed wire or something, ground wire, concentric or something, what you're going to do is you're going to use a zero ohm extension on the end of your tool, because you know how these tools work. And what you're going to do is you always use your proper accessory. I don't necessarily have to use the gloves for this, but just kind of gets the point across maybe a little better. Got the battery. So 3 kV power supply, this is our new design. Take a Milwaukee or Makita battery platform. It's kind of cool. No one else has that. And then what we're going to do is we're going to put a zero ohm extension. I have it in URD. Make contact with that conductor. But now we have the zero ohm extension. This is a little over 3,000 volts here, but it's high frequency, so it's not going to bite you too hard. Okay. I'll come over to you guys. Look, well, conductor. Okay, you guys see that? So what you do is you're taking that scenario when you inspect, that you know that your tool, if you use it in close proximity, or if there's a bleed wire or a ground plane near the meter head, you know there's current flowing through it because it has to in order to give you that voltage indication. You know that if there's a ground plane, maybe a cabinet door, maybe the cabinet's real close, that wire is real close, or you're in a substation scenario where you got you're touching a hot phase and you got a hot bus nearby. You know that you don't want that meter head that has that current from that phase flowing through it next to that ground plane or other hot phase. So what you do is you use a zero ohm extension and you go from this not a good scenario potentially to working safe. You guys get that? Yep. It works so good. A lot of utilities are doing this. And all that arc flash calls that we used to get, your tools suck, they're no good, it all goes away because it never happens again. All right. So zero ohm extension. Okay, buddy, I'm gonna have you take the PD25 recorded tool. Okay, go ahead and take that. And you can stand over here initially so that Mr. Adam can get this, and then I'll come over here so they can see that. But what I'm going to do is I'm going to come in and work unsafe because I never got this training. So I never knew it was unsafe. And I'm going to go ahead and come to this hot bus here, and I'm going to be short stick. Again, I never gotten this. Let's do it where I'm working safe first. All right, go to my boot, hold on. There you go. Okay, what you get?
Still getting nothing.
Okay, good.
Zeroed out.
All right, go ahead to my back.
2.
2 volts.
Yep.
Okay, go ahead to the inside glove. Make a tunnel.
1.
1. Okay.
1 to 2.
1 to 2. So the electrical reality is when you guys are working hot, even when you're working safe, that current is flowing across your gloves and through your body. Yeah? True, isn't it? Okay, now I'm going to short stick because I've always done it, and guess what? No one's ever told me different. All right, go ahead to the boot.
2 volts, 3 volts.
Okay, so a little more than last time, isn't it? Okay, back.
5 volts.
A little more, isn't it?
Yep.
Okay, inside glove.
6 volts.
All right, let's do it again, Ross. Now, I'm going to tool glove. Okay, boot.
Low. 13 volts.
Okay, back.
20 volts.
Okay, inside glove.
22.
All right. You guys see here? Okay, that is your electrical reality. If you don't understand that enemy right there, I've done this on our trailer when we come out with 19.9, and I've had easy by short sticking over 200 volts on my gloves and my back on 19.9. Easy over 200. One time we were in Homestead, Florida, just south of Miami there, at that municipality, and it was misty. You could actually see the water droplets slowly floating to the ground, and we got over 800 volts on my back. Okay, and we had to hold the end of the accessory, that straight probe, tight to my back because it was arcing a little bit. It was biting me a little bit. Okay, and you guys, so it depends on your environmental conditions too, right? So think about your minimum approach distances. Minimum approach distances on a day like today, which is dry, they're pretty good, pretty solid. But you get some of these swamp britches days that you're working in the summertime, and there's a lot of humidity out there and you're soaking wet. You've got to think a little safer than when it's dry, because things happen and incidents happen. Isn't that right? See? Okay.
A foggy day is one of the worst.
It is.
Really foggy.
It's bad. And you got to be extra safe, and that should be part of the tailboard, right? Everybody needs to talk about at that tailboard, that job briefing on the site. Go through that tailboard, write it up, and practice. Check this out. Practice going to Ross and encouraging him, and just say, hey, Ross, one guy at a time, one person at a time. Ross, are you concerned about anything here today? Do you have any concerns? After the tailboard's done, do you have any concerns? And Ross says, you know what? It's freaking foggy. And this stuff's going to bite us more and wants to bite us more because I understand the electrical reality of what we're working within, and we need to be extra careful today than we were on a normal day. Man, Ross, that's pretty cool. And you guys need to write this up and talk about it and go around. Do you have any concerns? Everybody needs to share and encourage that. Encourage all your folks to share. Okay? Because every one of you guys are gifted. Every one of you guys are geniuses. Truly. Any of you guys been doing line work for more than 10 years? Anybody? A few? Okay. So to get a PhD takes an average about 9 years and something months. Is the average PhD. Yeah. If you all been doing line work for more than 10 years, you have a degree, you have a PhD in line work. It's a fact. And you're very intelligent, very smart. But you need to allow that learning, that gift that you have, you need to allow others to start learning and sharing what they have. Because maybe Ross has never done any work with his hands. He grew up maybe playing video games. All right? His hands may be soft when he first started. You guys put up with him.
Still are.
Huh?
They still are.
Yeah, it's still up. All right? And you guys put up with him. But he still has gifts that he can share with you guys. Even though he may not have your experience, he still has gifts. And you need to tap into these resources that you have, which is yourselves. Okay? Very good, Ross. Okay, we're running out of time, so that's all the help I need you with. Okay? Thank you.
Yes, sir.
Appreciate it. All right, so let's go to the next thing. So proper body position, proper tool, energize, uncoupling with capacitance, working unsafe compared to working safe. Corded phasing safety, we're going to go over this real quick because we kind of talked about this before. Again, stay 36 inches away from your cords. If you've got a long cord, let's say you're high potting, do not have the cord circled up near you on the ground or wherever it's circled. Try to get that cord in parallel with itself. Remember what we did with the grounds tester and those TPGs? Run that cord, if you're using the one you could have on the ground, go ahead and run it out somewhere and kind of parallel with itself. Don't let it stay coiled up, okay? It's a lot safer. And just stay 36 inches away from it. Real quick, an electric cooperative in Texas called me up and said, hey, we were using your PD25 and we had an arc flash incident. Guys barely almost got hurt. And you know, we don't have confidence in your tool. So I'm like, okay, let me fly out and I'll give you guys some lineman safety and tool training at the time. And then we'll talk about it and see what you guys want to do about that. So I flew out there and basically the two linemen that the incident happened to be there, and they told me everything that took place. Okay, and it was neat to see them because they were able to tell me. Can you imagine? This was a close call. It was a very close call, and one of them could have got killed, or step potential could have lost their leg. All right, very close call. And what they did is they used the PD25, and they went to that hot bus. They stayed 36 inches back from their meter head. They were trained at, which is good. And they stayed 36 inches away from their cord because they were trained at, and that's good too. And when they went to that hot bus, there was another hot phase right next to the meter head. And what happened was, you guys know how these tools work. You already know what happened. Sure enough, they had a cross phase, and it flashed over to the tool. That potential went, remember it skipped, here's the resistors. The potential skipped the from this phase, skipped all those resistors. Full potential went down the cord, exploded at the secondary probe that was on ground, and exploded here. All right, and the linemen went running, screaming, dropped all their tools, went running, screaming. They told me everything. But what if the linemen? So no one taught them about keeping your air dielectric. No one taught them that you can't have a component of your system in close proximity to the meter head. No one ever taught them that. No one ever taught them that meter's energized. No one ever taught them that. Everybody's tools are when you use them. That's how they can indicate voltage. That's how they can verify you're in phase or out. They have to be. And what would happen if one of those guys had that cord next to his leg, next to his thigh with that full potential? Yeah, it would have not been a good picture. That was a very close call. So be aware of these things on your corded meters. I always go on whatever I want to talk about, but
Yeah.
Okay, this is a good one. Complacency. Here's some training sessions done around the country, but here's some javelinas. So some of you guys were talking about Arizona. I grew up in Arizona for 49 years, and I used to hunt Arizona all the time. Elk, muleys, hogs, bears, everything, turkey. And that's the only thing I miss about Arizona, by the way, is the hunting. Hunting was good. So see these hogs right there, those javelinas? So these javelinas are in the desert, and I'm hunting on the east side of Roosevelt Lake. So thing about the javelina, if you've got water nearby and you got prickly pears by, you're going to have javelina nearby. So you always look for that habitat. So I'm hunting, I got my bow and I'm hunting, and I get on this big boulder. I get on the big boulder, and on this boulder I'm just glassing. Really great. They got a hill, a lot of prickly pears, the sun's in the west setting, so it's behind my back, so I can see clear because I'm working. That's how you hunt. In the morning, you want the sun at your back, so you're hunting this way. In the afternoon, you're hunting this way. All right? So you can see clear. And all of a sudden, this herd comes up towards that boulder. They come up to the boulder that I'm sitting on with my bow, hunting these guys. And they come up to the boulder, and they lay down and rest. They take a little nap, okay? And when they take a little nap, okay, which one of you guys are the biggest one? I'm looking, okay, so, and it's like, you know what? This is too easy. I am not going to kill a javelina. I'm just not. This is not hunting. It's way too easy. So what I did is I had a stone, and I lobbed a stone in the middle of them. And they heard that stone hit, and they just went scrambling, running, about 80 feet away. And they stopped, and they looked around. They stopped. Okay, that's how they talk. I talk to them too. That's why I can't kill them. You start talking to them, you become friends. Okay, so it's actually a true story. I can't hunt them. So then all of a sudden they came right back to the same spot and laid down right in front of me. So what happened was I got another stone on top of that large stone, and I just lobbed it in the middle, and they ran, and check it out. They ran about half the distance. Not the full 80 feet, about 40. Start talking to each other, they calmed down, and they came right back. And then I lobbed the third rock. And what happened when I lobbed the third rock, they just jumped up and stood there. They didn't go nowhere. Now that arrow I had, and it was a nice bow too, it shoots good. That arrow I had is electricity. That electricity, I could have taken out any one of those javelinas because of their complacency. They were so good at thinking they were the very best. What does this say? Feeling so satisfied with your own abilities or situation that you fail to work as a line team. Huh? I take the meanings and I add a little you guys in it, right? They failed to work as a line team. And that's what happened. They failed to work as a line team. They actually should have recomposed and set up and say, hey man, this is just not normal. And it's not part of our procedures. Our procedures is we scatter every time. That's how we've been trained. That's how we live. We run as far away as possible to make sure it's safe, and then we regroup. Well, then it happened again, and they only went halfway. How many times do we learn how to do things properly, and then we go out there after a year or two, we topped out. Ross is now a lineman, and Ross is so good. He thinks he's on the top of the world, and what he does is he becomes complacent and he gets hurt. Or the folks watching him, because now he's a shepherd of the other apprentices, they watch him and they do the same thing. Because remember that poem? I've done it 100 times before. That's what they did. I didn't kill them, I didn't want to. I couldn't. Okay? But electricity doesn't think like that. Electricity is a beast and it's trained to take you out. Here it's a blessing because it's under control. It's got a leash. But out there, it don't have no leash. If you get a chance to escape from its wild pen, it's going to escape and it will tear you up. Fact. Okay? All right, accountability. All right. It's past 10. I can keep going a little further. What do you guys want to do? You tell me.
Yeah, go ahead.
You sure?
Yeah.
Yeah, keep going.
Okay, all right. Accountability. This is super important. This is what I've seen in the industry after 7 years being out with you guys and talking with other linemen. This is what I've seen, is a lack of accountability. And there's two accountabilities. There's personal accountability, fit for duty, all right, personal accountability. In other words, what did you do prior to you coming to the job that day? What were you doing? Were you preparing yourself? Did you have a good meal? Did you get some good rest? Or, like me, I have some friends I haven't seen in a long time. I go out and drink beers. I drink beers with them till 5 in the morning. I got to be at the shop by 6. I'm young. I can handle it. Guess what? I was not personally accountable to my whole crew that morning because of what I did prior to coming to work. And that's the thing I see that is one of the biggest attributes to incidences is a lack of personal accountability. One guy was speaking to me and is getting close to retirement, told me when he was an apprentice, he went into the line truck with the foreman, and the foreman stunk. The foreman was drunk in the truck, and this was like 25, 30 years ago. And they went out to the job site. The foreman passed out and slept. while the apprentice did all the work on his own without anybody watching. Nobody watching. Just think if that lineman, 4 hours from that time, woke up, the journeyman woke up, the foreman woke up, and that apprentice was on the ground dead. Well, that would have been a good one, huh? Could have happened easily. And instead, he worked in a situation where that apprentice was fearful and afraid that if he said something, say, hey, you're not accountable today to me and my life. And I want to have kids and get married one day and live life, but you're here in this truck, you stink, you obviously were up, you're falling asleep, you were up all night, and you haven't been personally accountable to me, so guess what? I don't want to work with you. He was afraid to say that. But we need a system in place where we cannot be afraid to say things like that and just be honest with each other. And I guarantee you, if he had that in place, if that company had that in place, and he would have said something, see something, say something, right? If that was in place and it was safe and it was built in the capacity to do so, and he did so, that foreman probably that would have been his last time doing that, and he probably would have changed his ways. Maybe, I don't know. But we got to work on these things. The mutual accountability is when you're on the job site. So Ross and I, we're on the job site. Ross, is your head in the game? So we make contact. Yes, every job, every task. We go from point A here in Statesville to point B. New job, new task. Ross, are you going to be mutually accountable to me today? Every job, we're going to ask and talk to each other about these things. We got to talk. We got to communicate. Several years ago, there was 2 linemen working, and they were changing out a broke pole. It's a true. All these stories are true. I got so many. It's a joke. And what happened was, and they were working hot, and they knew it was hot, and they had their game plan in place. The guy, they were good friends too. The guy that, well, I'll tell you in a minute. So the guy was pulling the log out of the trailer to replace the pole with the boom. And the boom came in contact with the energized lines, energized the truck. At the same time that the 25-year journeyman lineman was in the truck pulling out gear. And that journeyman lineman, for that split second, took his hat that said journeyman lineman off, and he put another hat on that said, I'm ground plane. And that potential went through him, 7,200 went through him, dead. In just a split second, even quicker, his wife lost her husband and the kids lost their dad. All right? So let me ask you a question. The guy that was running the boom, when this took place, was he mutually accountable to the guy that got killed? Was he mutually accountable? Wasn't, huh? They were friends. Okay, remember that poem? They were friends. He didn't know where his buddy was. If he knew his buddy was in the truck, and he realized and was paying attention that boom's going to come in contact with that energized line, he wouldn't have done it. He wouldn't have done it. But he wasn't mutually accountable. Now think about this. The guy that went in the truck to get the gear out, friends with the guy on the boom. Do you think that Mr. James, who got killed when he went into that truck, do you think he would want his friend to survive the incident, knowing that he was a big cause of the incident, the guy working on the boom, his buddy, and have that weight on his shoulders the rest of his living life as he enjoyed his family and his kids growing up and all the holidays and everything? Do you think he would want that burden on his shoulder? He's gone. So was he mutually accountable to the guy working the boom? No, not at all. You see, the victim isn't just the victim. The victim is everybody. Kids, family, everybody. So we got to be personally accountable prior to work in order to be fit for duty, before we're on duty, and then we have to be mutually accountable to one another while we're on duty. All the time, constantly.
This book is about human interaction. I want to help you become more effective as you interact with others, coworkers, friends, family, really anyone. In the book, I define the path to inclusion and innovation based on psychological safety. Psychological safety means that you feel safe interacting with others without fear that you'll be embarrassed or punished in some way. The pattern I share in the book is a universal pattern that I've discovered as I've worked with teams and organizations around the world. It's also, quite frankly, the key to happy and healthy relationships. We all have an inborn need to do 4 things when we interact with each other. First, we want to feel included. That's number 1. We long to belong. Humans need to be accepted before they need to be heard. Second, we want to feel safe to learn and grow. That means being able to ask questions, give and receive feedback, experiment, and even make mistakes. Third, we want to feel safe to contribute. That means being able to participate as a member of the team, using our talents and abilities to make a difference. And fourth, we want to be able to challenge the way we do things, to look around and say, you know what, it's time to change, and I have an idea about how to make things better. These are the 4 stages of psychological safety. 1, to feel included. 2, to feel safe to learn. 3, to feel safe to contribute. And 4th, to feel safe to challenge the status quo. We thrive in environments that respect us and allow us to do these 4 things. If we can't do them, if it's emotionally expensive, fear shuts us down. It triggers what we call the self-censoring instinct. And when that happens, we hold back and manage personal risk. And we're not happy or reaching our potential. But when the environment nurtures psychological safety and we feel safe enough to do these 4 things, there's an explosion of confidence, engagement, and performance. Here's my invitation. Read the book. As you do, crack yourself open and take a look inside. Ask yourself if you feel included, safe to learn, safe to contribute, and safe to challenge the status quo. Finally, ask yourself if you're doing all you can to create an environment where others can do these 4 things. In the process, I hope you'll look around and see others with respect and fresh amazement, find deeper communion in your relationships, and more happiness and satisfaction in your own life. Enjoy the book.
That's what's missing, folks. In our industry, that is probably, it's not this that's missing. We got this, but that's what's missing in our industry. And we can change it, okay? That's part of what ECOS is all about. All right, here, I'm gonna use an analogy because I like hunting and stuff. I'm gonna use an analogy of the elk. Take those 4 things that Timothy R. Clark spoke about. Take those 4 things and watch how these elk use those 4 things to survive. Okay? Watch this. And like, if you want to be the best, learn from the best. And what I was sharing with you earlier today is you guys are the very best. You guys are the very best. It's not outside these walls. It's all found within each one of you all. It's your very best. And we need to share that together. All right? So watch this. This is cool. This is fun.
There are those that say, if you want to be the best, you've got to learn from the best. From the winter range to the summer range, from spring calving to the autumn rut, Row Hunting Resources brings you the best teachers in the field. The elk themselves. Bringing you extended video of raw behavior and vocalizations. The gallery allows you to watch, listen, and learn.
Pretty cool. So no task is more valuable than human life. Working safely is a condition of employment and team. Working safely protects much more than you can see at any moment in time. Okay? This is why we do it. And you guys have the same. All right? Any questions? Any concerns? Okay. If you have any questions, I gotta pack up so you guys can ask them, but you guys.
Can he come to total?
What's that?
Can he come to total? I'm serious.
Yeah, I think it'd be good.
I think the linemen need to hear it.
Yeah. Seriously. You know, for a couple hours.
Yeah. Squeeze it.
Well, we'll see what we can work out.
I don't charge much.
I can tell them, and I do tell them, but I can't explain to you what it means with this guy that's got his stuff together, got his information. They listen. They listen to that, because that grounding test that y'all did, we're still trying to find the groove in the middle of the road with all that we've not finalized yet. And they hear what the man's saying, so I think they need to hear it.
Well, I'm glad you guys enjoyed it. After not doing this since May, I guess that's pretty good. No, one eye too.
Yeah, well, thank you so much. We'll see you guys about what we can do. Here's the cool thing too. Y'all are only a couple hours from here, right?
Yeah.
And they've got a training facility, so he and I are going to be pen pals. And I talked to Thomas, and Thomas is pretty stoked about that.
Yeah.
So I think we're gonna see a relationship building. So.
Okay, guys. Well, I appreciate you guys, Jerome, having me come. Appreciate you guys. All right. And you guys know what job you had and task you have to do. So simple, and it's actually so fun. You know. And if you're in this work for the money, it ain't gonna work. The money is a byproduct, but you're in this because of each other and your families. That's it. The money is a byproduct. It's just a natural thing that takes place and you receive after you do your job. Watch out for each other. Keep the lights on. So
I agree totally. You know, in this profession, if you're in it just for the money, you won't be good at it, I promise.
Someone's gonna
and
get
everybody ain't cut out for this.
No.
You know, we're getting a lot of young guys into it. But I feel like some of them are just in for
For the money.
And they're gonna get hurt.
That's a big problem right now.
Yeah.
Everybody's gonna cut out for this.
Yeah, and they're gonna get hurt, unfortunately. So we gotta, I have heard was 100% preventable. There was no team effort. Zero team. I'm just being honest.
And you guys know, we talked about there was like a rash of contractor deaths, and the one in Cincinnati, I believe, his dad was the crew leader, and had to tell him multiple times, put your PP on. And you just go, and we talked about it. It's like, what kind of culture do you have when your own damn father's sitting there and he's telling you, instead of stopping and going, stop, what the hell are you doing?
But PPE needs to be looked at as a fallback. It's not the reason why you're alive. It's not even the reason why you work safe. PPE is just another element that you put into your work practices that help you fail safely. Because you really don't want to allow your PPE to be why you're alive today. Because you have distances, you have procedures, you have these other things that are in place. The PPE is just simply put in place. Oh, you bump your head on that conductor with your hard hat. Well, good thing you had your PPE on, but why were you so close to that friggin' conductor? You see what I'm saying?
Amen.
All right.